Treasurer sir, good evening sir.
Good evening sir.
Treasurer sir, welcome sir.
Thank you. Good evening sir.
Sir, the audio வந்து audible இல்ல sir. Mic on பண்ணுங்க sir.
On பண்ணிடுறேன் sir.
Principal sir.
Sir. Sir, Treasurer sir.
Yes, sir. Sir. Yes, sir. Start, sir. Yes, sir. Yes, sir. Yes, sir. Sure, sir. All the best, sir.
Okay, thank you, sir. Thank you. Chief Guest, sir, Chandrasekhar, sir.
Sir.
Sir. Yes, sir. Yes, sir. Yes, sir.
Sir.
Yes, sir. Yes, sir. I'm connected.
Okay, sir. Okay, sir.
Sir, voice கேக்குதா sir?
Yes, sir. You're audible, sir. Yes. Sir.
Okay, thank you, sir. Thank you.
Thank you.
Good evening to all. It is my privilege and it gives me an immense pleasure to start this auspicious occasion by heartily welcome everybody to this webinar on spectroscopy and its application on environment. First of all, I welcome the most respected, believable and lovable secretary and correspondent of our college, Mr. T.A.S. Muthu sir. Once again, I welcome sir. Then I welcome the most respected treasurer of our college, Mr. M. Srinivasan sir. Once again, I welcome sir. Then I welcome our academic dean, Professor A.L. Udayappan sir. I welcome the most accepted, believable and lovable, the principal of our college, Professor Dr. K. Anandraj sir. Once again, I welcome sir. I welcome my dear friend and the HOD of Mathematics, IPSC coordinator, Professor Dr. Murugan sir. I welcome the most respected chief guest of this webinar and my dear best friend, Professor Dr. A. Chandrasekharan sir, SSN College of Engineering, Chennai. Once again, I welcome sir. I welcome all the heads of the department and my dear faculty members from other departments, staff members, supporting staff members, all of you I welcome sir. I welcome my dear students, young and energetic, young scientists of our nation, our department students. Once again, I welcome all of you for this webinar. Thank you. First of all, I welcome the most respected treasurer of our college, Mr. M. Srinivasan sir. Please give your felicitation address to our webinar. Treasurer sir.
அனைவருக்கும் ஓகே சார். அனைவருக்கும் எனது மாலை வணக்கம். நமது சண்முகா தொழிற்சாலை கலை அறிவியல் கல்லூரி 25வது ஆண்டை எட்டியுள்ளோம். இந்த நன்னாளில் நமது கல்லூரியில் PG and Research Department of Physics and IQAS நடத்தும் வெபினார் ஆன்லைன் வழியாக வருகை தந்திருக்கும் அனைவருக்கும் எனது மாலை வணக்கம். மற்றும் நமது கல்லூரியாளர் T.S. முத்து அவர்களுக்கும் மற்றும் நமது கல்லூரி உடையப்பன் சார் அவர்களுக்கும், நமது கல்லூரியின் எனர்ஜெட்டிக் பிரின்சிபல் டாக்டர் கே ஆனந்த் அவர்களுக்கும் மற்றும் HOD ஆஃப் பிசிக்ஸ் டிபார்ட்மெண்ட் ஆர்மோன் சார் அவர்களுக்கும் மற்றும் அனைத்து பேராசிரியர்களுக்கும் துறை தலைவர்களுக்கும் மற்றும் அனைத்து இதில் கலந்து கொண்டிருக்கும் அனைத்து மாணவர்களுக்கும், நமது பல்வேறு வேலைகள் இருந்தாலும் அந்த வேலைகளை ஒதுக்கி வைத்துவிட்டு நமது கல்லூரிக்காக நேரத்தை ஒதுக்கி தந்த நமது சிறப்பு விருந்தினர் டாக்டர் கே. சந்திரசேகரன், அசிஸ்டன்ட் ப்ரொஃபசர் ஆஃப் SSN காலேஜ் அவர்களுக்கும், கல்லூரியின் சார்பாக மாலை வணக்கத்தை தெரிவித்துக் கொள்கிறேன். எங்கள் அனைத்து பேராசிரியர்களும் உழைத்துக் கொண்டிருக்கிறார்கள். இந்த சூழலிலும் மாணவர்களுக்கு எவ்வாறு பாடுபட வேண்டும், அவர்கள் வேலைவாய்ப்பை எப்படி பெற வேண்டும் என்று பல்வேறு ஸ்டெப் எடுத்துக் கொண்டிருக்கிறார்கள். எங்கள் நிர்வாகம் பேராசிரியர் அவர்களுக்கும் அனைவர்களுக்கும் நிர்வாகம் கடமைப்பட்டிருக்கிறது. நன்றி கூறுகிறேன். இந்த சமயத்தில் நன்றி கூறுகிறேன். மற்றும் இவர்கள் செய்வதை மாணவர்கள் சிறப்பாக பயன்படுத்திக் கொள்ள வேண்டும். இவர்கள் கஷ்டப்பட்டு பல பேருடைய அப்பாயின்மெண்ட்லாம் வாங்கி இதெல்லாம் செய்யறாங்க. எல்லா டிபார்ட்மெண்ட்லயும் சரி. நேற்று கூட இந்தியன் லைப்ரரி இதுல அப்பாயின்மெண்ட் ஐஐடி வாங்கி செய்யறாங்க. அதெல்லாம் லைப்ரரி இதுல நிறைய யூஸ் இருக்கு. அதெல்லாம் மாணவர்கள் கண்டிப்பாக அதெல்லாம் பயன்படுத்தி மாணவர்கள் தயவு செய்து இதையெல்லாம் பார்த்து இதெல்லாம் இந்த வெபினாரை இதை அவசியம் பார்த்து வாழ்க்கையில் முன்னேற வேண்டும். ஏன்னா உங்களுக்காக உங்கள் தாய் தகப்பன், கல்லூரி நிர்வாகம், ஆசிரியர்கள் மற்றும் இவ்வளவு பேர் உங்கள் உழைப்புக்காக நீங்கள் உயர வேண்டும் என்பதற்காக அனைவரும் உழைக்கின்றார்கள். நீங்கள் ஏன் கொஞ்சம் உழைக்க கூடாது? உங்கள் உயர்வுக்கு நீங்கள் கொஞ்சம் உழையுங்கள். அதனால் இந்த மாதிரி வெபினார்கள் கலந்து கொண்டு பல்வேறு துறை சம்பந்தப்பட்ட வெபினார்கள் கலந்து நீங்கள் உங்கள் அறிவை வளர்த்துக் கொண்டு வேலை வாய்ப்பை அதே சமயம் இந்த நேரத்தில் சொல்லிக் கொள்வது என்னென்றால், இந்த கொரோனா பீரியட் வேலை வாய்ப்பு இல்லை. தயவு செய்து தன்னம்பிக்கையாக இருங்கள். கண்டிப்பாக வேலை வாய்ப்பு இருக்கின்றது. படித்து நன்றாக ஒரு அறிவு இருந்தால் கண்டிப்பாக வேலை வாய்ப்பு இருக்கிறது. இன்னும் கொஞ்சம் போராட வேண்டும். போராட்டம் கம்மியாக இருந்தது, கொஞ்சம் போராட வேண்டும். போராட்டம் நீங்க செய்தால் கண்டிப்பாக வேலை வாய்ப்பு இருக்கிறது. அதனால் இந்த கொரோனா காலத்தில் தயவு செய்து தன்னம்பிக்கை இழந்து விடாதீர்கள். தன்னம்பிக்கையோடு இருங்கள். அனைவரும் நன்றாக படித்து வாழ்க்கையை முன்னேற வேண்டும் என்று வாழ்த்தி விடைபெறுகிறேன். நன்றி, வணக்கம்.
Thank you, sir. Thank you for your inspirational speech, sir. Now, I would like to invite our college principal, Dr. K. sir, to deliver his.
Thank you, sir. Happy evening to all. Most respected Secretary and Correspondent, Mr. T.A. Muthu, sir. Most respected Treasurer, Mr. M. Srinivasan, sir. Most respected Academic Dean, Professor Udayapan, sir. Most respected Convener and Head of the Department of Physics, Dr. S. Arumugam, sir, who delivered the welcome address. Most respected Chief Guest of this function, Dr. A. Chandrasekharan, sir, Assistant Professor, Department of Physics, SSN College of Engineering, Chennai, and beloved faculty members, Ms. P. Ramya, who is assigned to deliver the Chief Guest introduction, and Dr. G. Lakshminarayanan, who is assigned to deliver the vote of thanks. Other faculty members, like Dr. Gopinath sir, who is hosting this program, other faculty members of this physics department, and disciplined student of this department, dear participants, once again, very happy evening to all. Really, I'm very happy to be a part of this program, that is one-day webinar on spectroscopy and its application on environment. As a science person, I know that it have the wide applications in various fields. I think it is playing an important role in the research. That means without spectroscopy research will not be playing. It is playing an important role. So the topic is very hot topic, and the chief guest, I gone through the website SSN, that is Dr. Chandrasekharan sir I gone through the that is biodata of our chief guest. Really around 200 and more than many of the publications, citations 112 citations, H index is 20, I-10 index is 29. So really a very apt person. So such an eminent researcher is joined with us in this evening to share his research knowledge with the researchers and the students and the faculty members. So I request all the researchers and students to observe, congratulate, and I wish the head of the department, Dr. S. Arumugam sir, and the faculty members and the students to have a great success of this webinar. Dr. Chandrasekhar sir, on behalf of my personal, I thank sir for joining platform, virtual inaugural address in this webinar. Thank you very much, sir.
Thank you, sir. Thank you.
Thank you.
Thank you so much, sir. Now I request our Faculty of Physics, Ms. Ramya Madam, to introduce our speaker for the day, Dr. A. Chandrasekharan sir, SSN College of Engineering, Chennai. To our esteemed audience.
It's my honor and a privilege to be introducing our chief guest, Dr. A. Chandrasekharan sir, respected secretary and correspondent, Mr. T.S. Muthu sir, treasurer, Mr. M. Srinivasan sir, IQAC coordinator, Dr. P. Murugan sir, all staff members, my dear students and friends, very good evening to one and all. I am Ramya, Assistant Professor, Department of Physics. We are honored this evening by the presence of Honorable Chief Guest webinar on spectroscopy and its application. Dr. A. Chandrasekharan sir has an Assistant Professor, Department of Physics at SSN College of Engineering, Chennai. He has more than 12 years of teaching at college level. Our chief guest did his PhD in the field of molecular spectroscopy at Government Arts College, Tiruvannamalai, under the supervision of Dr. Ravi Shankar sir. He received the Best Lecturer Award for the Outstanding Academic Performance in the year of 2012 to 2013. Sir has presented more than 50 papers in peer-reviewed journals. Also, he presented a paper entitled Radioactivity and Cancer Risk Assessment in 4th Asian and Oceanic Congress on Radiation Protection, IRPA, Malaysia. He has an invited talk at various institutions. He has received a Best Paper Award in the 19th National Symposium on Radiation Physics. He is working as a co-investigator of BA of 22 lakhs, as also working as PI on SSN-sponsored internal project. Young Scientist Award by Venus International Research Foundation, India in the year 2018. He is also author of Engineering Physics book in Science Tech Publications and a lifetime member in Society for Radiation Research, India. Our alumni students are joined PhD under his supervision. Currently, one student submitted his PhD. Thank you for giving this wonderful opportunity.
Thank you, ma'am. Thank you, ma'am. Now I request our chief guest, Dr. A. Chandrasekharan, to deliver the speech on this topic.
Sanmoga Industries College Management correspond to station, and let me share my screen. I hope that you are able to see my computer screen.
Yes, sir.
Okay, thank you very much, sir. So today the topic of discussion is the spectroscopy and its application on environment. The spectroscopy is a very wide range of topic. So without the spectroscopic techniques, we cannot enter into the field of any field of research. So what is the spectroscopy? This is spectroscopy about the interaction of electromagnetic radiation. So not only the spectroscopy deals with the interaction of light with matter, also it extended the interaction of some basic nuclear particles like electron, proton, neutron with some other materials. So this interaction will provide the basic information about the materials and new information about the material science. Particularly this spectroscopy plays a major forensic, engineering, astronomy, agriculture about the spectroscopy. Some fundamentals we will discuss now. So when we talk about the spectroscopy, so without electromagnetic spectrum, so nothing in spectroscopy. So there is some electromagnetic emitter. It's a sun is main source of electromagnetic emitter. So the electromagnetic components, magnetic and the electric components. So that electric and magnetic are recorded as a spectrum. This recording spectrum is varies with the wavelength and the frequency range of this. And then when we study the whatever material with the interaction of light or some other material, other light radiation, there are two cases, so low energy and high energy states are there. There's a ground state and excited state. Atoms and initially the atoms and molecules in ground state emission. So in absorption case, what happens? The ground state to excited state, atoms and molecules excited from the absorption of external energy and goes to the excited state. Then in emission case, excited state, for atoms and molecules de-excited from the excited state to ground state with the emission of absorbed radiation. So based on these two phenomena, there are two spectroscopies, absorption and emission case. Electromagnetic field, just now I have shown that radiation consists of two components. That red color dotted line shows that the magnetic. Using this, the distance between the when waveforms we have studied that nodes and antinodes. The nodes and antinodes. The distance between the two antinodes are wavelength we call. Then the electromagnetic wave you take, the important parameters are wavelength and the frequency. So in case of frequency, the first case the amplitude time, the 1/d time is the frequency. So wavelength, frequency, and one more case is intensity is there. So all intensity comes under only the optical radiations. In case of electromagnetic radiation, the wavelength and the frequency is very important parameters. Then why this spectroscopy and where this spectroscopy is originated? The spectroscopic, the word origin spectron or ghost or spirit. So in electromagnetic radiation, different regions are there, only particular region only visible region. So others are invisible. There are energy levels, ground state and excited state energy levels. So this, if you take any material like solid state.
Sir.
Yes, sir.
The slide is move, sir.
Move, in the slide, sir.
Move, sir. Electromagnetic. Yes, energy levels, sir.
Yes, energy levels. Okay, energy levels. Okay.
Thank you.
So in energy level, so the ground state and the different energy excited states. So once the energy is absorbed by the atoms and molecules, that reaches the various energy states. So E0, based on that we can give name E0 is ground state, E1, E2, E3 excited states. So these states are there are two types: electronic excited states and vibrational or rotational excited states. In electronic case, the electrical energy, once electrical energy is observed, that's electronic states. Maybe the external energy, maybe electrical energy or thermal energy. Based on that, the thermal states, thermal rotational states, or thermal electronic states. So we can give then vibrational states. So in vibrational case, liquid and gas molecules, the atoms and molecules starts to vibrate or rotate based on the energy provided to the material. So this fundamental is very important to produce the spectrum. Once energy is observed or emitted, then only spectrum produced. So this absorption and emission is important in the case of energy level. This energy, the supplied energy should be equivalent to the energy difference between the ground state and the excited state. That is delta E. Delta E is equal to E1 minus E2. So this is what we have studied as a Planck's law. Planck's law equal to h nu. E equal to 1 h nu, 2 h nu, 3 h nu. Like this we have studied in quantum mechanics. So once in order to observe the energy by the atoms and molecules, the required energy should be equivalent to the energy gap between ground state and the excited state. So that is the condition for absorption or emission. So once this condition is satisfied, some spectrum is produced. So this is the vibrational and rotational states. When draw the graph between internuclear distance of one single atom, you take internuclear distance and potential energy. This maybe we studied in a theoretical subject like a molecular spectroscopy subject. Some rotational, that's horizontal lines, so some rotational states and vibrational states are produced. So based on this fundamental frequencies, frequency 1f, 2f, 3f, this is what I told initially, nodes and antinodes. Agadu, Mugadu, like this, the waveforms are produced. So in each vibrational states, see for example, take first V is equal to 1, means only one waveform generated, half wave. Then second V is equal to, second vibrational state produces the one entire waveform. Then third wave, then fourth vibrational states, and so on. Similarly, number of E1, if one photon is observed, or one E equal to energy or some voltage energy, some potential in E equal to 1 volt, 3 volt or 3. Like if it is electrical energy, we measured in millivolt or volt. If it is optical energy, we measured in 1 h nu, 2 h nu, 3 h nu in photon level. So either electrons or photons in the in the nature of particle or wave nature, the energy is observed. Based on that, the vibrational modes are generated and spectrums are produced. So in case of absorption spectrum, in absorption spectrum, we usually will draw the graph between wavelength and absorption. That is absorption spectrum. And in for example, sodium, you take the fundamental molecular electronic state 3s2 3 p orbital, the sodium atom excited from s to p orbital and 3s2 5 p orbital, that produces the different spectrum, yellow color 589 nanometer of yellow color spectrum and 285 of ultraviolet region of spectrum. So these are due to excitations of atoms and molecules in visible region, and inner excitation and valence electron excitations, and core that's inner electron excitations. So now but since it's a fundamental, I'm briefing only the required content, because already we know that the atoms in what is atom, and inside the atom nucleus, just outside the nucleus electrons revolving on the nucleus, inside the proton and neutron is. These are fundamentals. I'm not detailing go through that fundamentals. Only the required content to do the research on MSc or PG level. So in general, in spectroscopy methodology in general, what is the expectation of researchers to find out the new things or new compounds from the materials? The energy of electronic from electronic state, vibrational state, rotational state, and symmetrical and asymmetrical modes of molecules from the spectrum. So usually, what does light to do the sample? First, when we talk about the spectroscopy, what does the light to do the sample? What light என்ன பண்ணும்? Once we apply the electromagnetic light or electromagnetic spectrum light to the sample, what will going to be happen? Then after that, after interaction, how produced? How spectrum produced just now we discussed, like transition from the excited state to de-excited state, and the spectrum generation of absorption and emission process, emission energy and absorption energy. And what exactly is spectrum a measurement of? Spectrum la நம்ம என்னால என்ன கண்டுபிடிக்க முடியும் மெயினா? So எப்படி interact பண்ண spectrum எப்படி produce பண்ணுது, spectrum ல இருந்து நம்ம என்ன தெரிஞ்சுக்கிறோம். So இதுதான் வந்து ஒரு expectation of a researcher when we do any new type of research or new type of project. These are the fundamental things. This is a fundamental question immediately raised from each and every mind of researchers. So basic idea, when we starting to the research on in particular material or particular work, the light interact with the sample. There are two cases. The characterize the light after sample. So light, what is the changes happens in the light? Like what is the parameters of light? Intensity, parameter, wavelength, and the frequency. Any changes are there, we have to observe. And then characterize the change in sample. So characterize the change in sample means in the liquid nature or solid nature changes. That's why we have classified the research techniques are non-destructive and destructive techniques. So non-destructive means the samples we are not able to use only one time use. Samples one time use for one particular technique. So destructive, non-destructive means we can use the sample for multiple techniques. So the first thing we have to think about before producing the spectrum, what is the changes in the reflected spectrum, reflected light from the sample, and then what is the changes happens in the sample. So in first case absorption, so initial intensity, we know the light parameters, electromagnetic radiation parameters. Just now I told wavelength, frequency, and intensity. If I0 is the initial intensity. After this, after this sample interaction, the emitted light or transmitted light intensity is I0. So what is the difference between I0 and I? So that we have to calculate, that is transmission T is equal to I by I0. So we measure the absorption of light at a different frequency and the wavelength. So the absorption frequency takes place always the peaks towards the y-axis. And emission. So emission case, after the light energy absorbed by the sample material, the light is simply scattered in different direction. So based on that, maybe the fluorescence happens or phosphofluorescence happens and the Raman scattering. So the different phenomena, the light rays are undergoes the different phenomena. So after the emission process. And optical rotation, so change of phase of light incident. Once the electromagnetic or any other light incident on material, the phase 1 pi, 2 pi, 3 pi, mathematically that phase changes. Like this we have studied in harmonics, simple harmonic and oscillators, harmonic motion, simple harmonic and other harmonic motion. What is pi, 2 pi, and 3 pi? So the three different cases, absorption and emission and rotation. During three different processes, the spectrum is generated and names are given based on the intensity of light observed or intensity of light transmitted. Based on that, names are given. And what are the axes used in the spectrum? Wavelength lambda, frequency nu, C by lambda, and energy E equal to h nu. So these are basic parameters used in the axis in spectrum. So in y-axis, we remember that B's law. It's a is equal minus log I by I0. So where I0 is equal to intensity of light in initial intensity, I is equal to after penetration through the sample. Then epsilon is equal to molar decade extinction coefficient. So these extinction coefficient values are very, very useful in environmental studies to calculate the available content of environmental samples, available in percentage level, 200%, 50, 60%, or 99%. How much of content in mainly environmental samples? Like in environment, you take troposphere and stratosphere, we have different gases. In atmosphere also we have oxygen, carbon dioxide, carbon monoxide, different gases are there. So when we use electromagnetic radiation to study the percentage, to calculate the percentage of gases in various layers of atmosphere and earth atmosphere, we can find out the percentage of carbon dioxide or carbon, nitrogen, and oxygen content. So that plays a major role in extinction coefficient. And the concentration of sample and sample length. If it is a solid sample, sample length plays a major role in the absorption spectrum. So in spectrum, X, what is the parameter in x-axis and parameter in y-axis? So when we talk about the electromagnetic spectrum, we should know the different parts of the electromagnetic spectrum, starting from gamma ray to radio wave. So different region have the different names and different their applications. So gamma rays used in the radioactive elements, and X-rays used in the medical, ultraviolet ray used from the sun, and the visible light. Visible light used almost we are using maximum visible regions like light emitting diode and OLED televisions and car and other almost all visible devices like solar panels, display panels from airport and train railway stations, and mainly the signal from road traffic are visible lights, and infrared radiation. Infrared LEDs are it's a colorless, it's invisible, but if we have using remote controls, almost all OHB remote control, TV remote control, and almost all remote controls are working based on infrared LEDs, and the microwaves used in microwave and the radio waves, FM and AM. So we know this. So different parts. So almost the size also compared with the real-time applications. And radioactive subatomic particle size, and atoms are size in 10⁻⁻10 wavelength of electromagnetic radiation, and bacteria and pinpoint places the building size are almost 10⁻³ meter, 3000, nearly 3000 meter of height buildings are there. So the wavelength of different electromagnetic radiation with the real-time applications. So different electromagnetic radiations used in the researches in gamma ray, even the gamma ray, X-rays, X-ray diffraction, and ultraviolet UV visible and visible light, the laser lights, like interaction of laser with the materials. Almost all color lasers are available, and infrared FTIRs and other infrareds are available, and the microwaves. So when we talk about this electromagnetic, already I explained this, what is the content of electromagnetic radiations, especially the visible radiations. In visible radiation, one important point is almost it is measured in Armstrong, 10⁻⁻10 meter, and nowadays in nanometer. Why I am giving much stress on visible region means it is visible, and it is used in day-to-day life. When we go to the railway station, you can see. When you go to the airport, you can see. When in traffic signal, in television, even in your mobile phone, there's some emission of light is almost interaction of this optical energy with the materials. So this is the visible spectrum I explained just now, and the X-rays, medical imaging, ultraviolet tanning lamps, and infrared rays used in heat lamps, and the microwaves used in ovens, and the radio waves are used in communication purpose. Yeah, now come to the main picture. So far we have discussed about the theoretical background and what is the application and how to classify the electromagnetic, how electromagnetic radiations are dominating our life. So day-to-day life and in the research. Now the types of spectroscopy. So based on the electromagnetic spectrum, see the first one is the main gamma ray spectroscopy. I am going from higher frequency to lower frequency, the gamma higher wavelength to lower wavelength. Gamma spectroscopy and energy dispersive X-ray fluorescence spectroscopy and X-ray spectroscopy, IR spectroscopy, UV visible spectroscopy, atomic absorption spectroscopy, Raman spectroscopy, then laser spectroscopy. So I will cover from gamma ray spectroscopy to almost UV visible or up to atomic absorption spectroscopy. So first we'll talk about gamma ray spectroscopy. So what is this gamma ray spectroscopy? Almost the study about the gamma interaction of gamma ray with the materials. That's a gamma ray spectroscopy. Even this interaction also produces the gamma ray spectrum. So basic gamma ray spectrometer determines the energy and the count rate of gamma rays, because these gamma ray particles are high energy particles. In the nuclear physics, we studied that three type of nuclear particles: alpha, beta, gamma. When compare all three particles, gamma rays high energy particles. So this high energy gamma ray interacted with the substance or materials, then produces this spectrum. So from this during this process, what type of data obtained from the materials? So before that, basic parts of gamma ray spectrometer is a detector. In gamma ray, in electromagnetic spectrum also contains the gamma ray. Also some other artificial materials like a cesium in nuclear cobalt, cesium, and some other materials. Even in nature, almost all environmental materials contains the gamma ray source materials. Like isotopes in periodic table, uranium, thorium, and potassium, and uranium-235, radon, radium, and radon contains. So almost all the material. Anyway, everywhere, each and every human being, animals, and plants receiving the gamma energy. So this reduction of gamma energy is very, very important. Hence, this gamma ray spectroscopy is important to detect the strength of gamma energy received by each and every human being, animals, and plants. So now each gamma ray spectrometer contains the detector and electronic system and multi-channel analyzer and a software system, spectral software system with the computer. So I will brief about the complete process of gamma ray spectrometer. So this is the first. This entire part represents the gamma ray detector with the shielded area, because people who are working with gamma radiation, they must wear the radiation protection coat, because it is harmful to human being. Hence, the gamma ray detector is completely shielded by the lead shielding. So the sample source means maybe this may be a rock or sediment or soil, or maybe cesium, even artificial source, cesium or uranium, potassium or cobalt. That source is placed on the detector. Once it's placed on the detector, the source emits the gamma radiations. That gamma radiations are undergoes the multiple reflection inside the aluminum coat, which is given inside the detector. So after the aluminum coating, only the detector is shielded by the lead shielding. So undergoes the multiple reflection, then produces the three different phenomena. One is the Compton effect, second one is photoelectric effect, and third one is pair production and annihilation. So this is the fundamental phenomena of nuclear physics. Like we know what is Compton effect, high energy monochromatic radiation interacted with low atomic substances. Then automatically what happens, the radiation is frequency of radiation increases. That is Compton effect. One radiation after the interaction, there are two components. One component similar to the initial one, that other component frequency increases. That increased components only observed by the various electronic component observer and converted into photons. Then photons are converted into electrons. That electrons produces the voltage. So some conversion process happens here. The commonly used detectors are scintillation detectors, sodium and iodide. These are low atomic substance materials. The low sodium iodide. This iodine is mixed with sodium due to activation of each and every photons. Whenever gamma ray photon interact with the material, that time energy is not sufficient. That time iodine is activated the each and every atoms and molecules to observe the photons. Then photoelectric effect, Compton effect, and pair annihilation and pair production is possible. After that, we know that conversion, photons from electron conversion, then electrons are counted by the software system. Number of counts, 1000, 10,000 counts, 2000, and each count represents the volts, 1 volt, 2 volt, 3 volt, like this. So if counts are more, the photons or gamma energies from the source is more. If counts are more, the energy, gamma energy from the source is more. For example, you take cobalt and cesium, the cobalt is high gamma energy content. Look at the picture given in the PPT. There are two images I given. The commonly used detector crystals. These are solid state flat type of crystal used in the gamma ray spectrometer system, and well type of crystal system. So samples or any material, if you want to measure the how much of gamma ray content, that material should be placed within the well or top of the detector. In top of the detector, there is a possibility of high error. In well side, the error is very less because the entire sample kept inside. But in flat type, only bottom side maximum count received from the bottom side. In wall side and top side, there is a chance to disappears the gamma ray energy. That's a reflection or annihilation is possible. But in well type, there is very, very less. Then advantage is very, very, very high. This is the available gamma ray spectrometer within our laboratory, our physics laboratory at SSN College of Engineering. This is the told gamma ray detector completely shielded by the lead shielding, and the electronic system and the software system. So sample, whatever sample should be placed inside this, and we have to completely cover, and the complete three process, Compton effect and the photoelectric effect and pair production annihilation happens within the shielding, and finally the produced gamma ray energetic particles converted into photons, and that photons only received by the electronic system, and the electrons are generated, and the electrons are produced as a number of counts in the spectrum. So I will show how spectrums are produced. See, these are channels we given. So each channel, 100 counts, 200, 300, number of channels are there. So each channel equivalent to the 1 voltage. So number of channels produces the number of counts. So this is the raw spectrum. This is the spectrum of one in building material like granite. So when granite should be in powder form, that material we have tested for gamma ray energy. So this gamma ray photons produced 3 different radioisotopes. So that the granite contains the major radio emitting isotopes, uranium, this is for thorium, and this is for uranium counts, and this is for potassium counts. So these 3 elements are identified from the granite building material, which shows the relevant availability of gamma dose. Because nowadays everyone using granite as a building material, even domestic and industrial application. So before we use that, we should know that the material is suitable for healthy living or not. So it is very, very important. So this is a clear using counts and energy. It's a channel. We have drawn this spectrum with origin spectrum. Bismuth is thallium. The thallium is the isotopes of thorium, and bismuth is the daughter product of uranium. So these are directly we cannot find out, because the spectrum isotopes are detected only because the available source and calibration and efficiency is done using only the ISO standards from the International Atomic Energy Agency. So that the standards are relevant to bismuth and thallium only. This thallium and bismuth materials are completely relevant to the uranium and the thorium. But the potassium is not like that. It's directly we can identify it. So this gamma ray spectroscopy is application in soil, sediment, sand, rock, water, fly ash, and building materials. So the different earth materials are there. These earth materials are used for manufacturing of various materials, and especially used in building materials. So these are the sand and rocks and different materials. So we know very well about we are aware about all the materials. So usage of this material is every day, day to day life we are using this material. Hence, this material quality is very, very important before we should know. So this is a gamma ray spectroscopy. Then next I'm moving on to the second one, energy dispersive X-ray spectroscopy. So in energy dispersive X-ray spectroscopy is the mainly the usage of X-ray. In an energy dispersive X-ray spectroscopy used to measure the chemical composition of samples. When we have a contaminated water in a leather near, if you are living in very near to the leather industry or any ceramic industry or any glass industry, your area is either whether it is your area is contaminated, either agricultural field is contaminated or your ground water level is contaminated or not. So to identify this, we can use the energy dispersive X-ray spectroscopy. So especially less than, if greater than, atomic number is greater than 3, we can use that this method to find out the chemical composition of the material. So this is a typical energy dispersive X-ray fluorescence spectrometer available in various laboratories. Especially this method contains 3 different. There is 12 sample holders. So at a time you can place the same 12 samples or different kind of samples you can place, and which is placed inside the instrument. So which is also produces the. But in electromagnetic is a natural source of X-ray. In EDXR we have an artificial source of X-ray. So in 10th class, I think we studied X-ray tube, X-ray tube. It had a radium as anode and cathode rays, and the power specification and all given by the as per company product of company, we have to fix it. Once the sample, this sample may be any kind of sample except liquid. In present case, it's a liquid. For liquid nowadays, we use inductively coupled mass spectrometry and atomic absorption spectrometry. This EDXRF only used for solid material. You can take any leaf, any medical plant leaf, you can test the chemical composition of that, or any agriculture soil. If you take agriculture soil, the required elements very, very important. Your talcum powder, any cosmetics also you can test using this. Any toxic elements are there. It is a good to human health or bad. So that the type of activities we can do using the EDXRF method. So one example I will show here. This is the fluorescence from the basic principles are nothing, the equipment, the interaction of X-ray with atoms and molecules of a sample. Then it produces the fluorescence. I told that after the emission process, there are three: phosphofluorescence and fluorescence and emission process. That's scattering. The scattering will be three different processes. I told that's the fluorescence is one of the process. So this X-ray fluorescence and the fluorescence it's a multiple scattering. So that produces the different energies, K alpha and K beta, and different regions. In absorption side, there will be a different peaks. So this spectrum shows the availability of different elements, especially the X-ray spectra with the incident beams above and below the uranium. So sediment samples. Sediment sample means river sediment. River sediment is important building material, and beach sediment. Beach sediment is important source of radioactive elements. So these radioactive elements are used in nuclear reactor to generate the electricity. So this either beach sediment or river sediments is an important earth material. We have tested for the identification of elements. So that shows the various components. So I will show with the raw spectrum. This is a raw spectrum like iron, germanium semiconducting elements, germanium, iron, and manganese, chromium, titanium, calcium, chlorine, oxygen, so krypton, strontium. So these type of elements identified using the EDXRF. But once we have a standard for calibration of equipment, we can find out our required elements. Elements are major and minor elements are there. Our human case, we have toxic elements which are harmful to human health, especially cancer causing elements, arsenic, lead, copper. So that cancer causing elements. So that elements are identified using EDXRF spectrum. The basic energies used in fluorescence spectrum is energy 7,112 electron volt. So different energies after interaction with the sample, the scattering takes place. That's a fluorescence almost. That fluorescence contains the different energies of X-rays. The different energy produces the different strength. So different energy produces the different elements. So the elements only we have shown here. So energy in electron volt and intensity. And the result after the result with the calculation, this is magnesium, aluminum, potassium, calcium, titanium. The results are completely displayed in the table. So S1, S2 represents the number of samples. Sample 1, sample 2, sample 3. These sample natures are almost the same, maybe river sediment or beach sediments or some rock type of material or agriculture soils. You can just, the values are given in ppm, like milligram per gram. So that much of very low level content up to this, we can find out the elemental composition of given samples. Not only earth material, we can go for the medical and food plants. This is spectrum. I will show this. This spectrum for squash plant. அப்படினா நம்ம என்ன சொல்லுவோம் அப்படினா நாட்டு பூசணிக்காய் அப்படி நம்ம ஊர்ல சொல்லுவோம். So அந்த பூசணிக்காயோட லீஃப் எடுத்து ஆர்சனிக் 5+ டெஸ்ட் பண்றோம் அப்படினா, because ஆர்சனிக் வந்து பாத்தீங்கன்னா உங்களுக்கு வந்து கேன்சர் காசிங் மெட்டல். So அதனுடைய டெஸ்ட் எடுத்து பார்க்கும்போது you can find out titanium, vanadium, chromium. So different peaks are obtained, but that contents are very less. But when we go for arsenic, that peaks is very, very high. இது வந்து பாத்தீங்கன்னா near to leather industry. Leather industries-ல they are using sulfur dioxide. Sulfur dioxide using for leather cleaning and polishing. That leather industry wastewater mixing with agricultural land. That then after that in that agriculture land used for cultivating that squash type of material plant. So on the plant வந்து leaf எடுத்து நம்ம பண்ணது இது. So இது போல வந்து நம்ம டிஃபரெண்ட் அப்ளிகேஷன் லைக் ஃபுட் இல்ல மெடிக்கல் அண்ட் எர்த் மெட்டீரியல் டெஸ்டிங் எல்லாத்துக்குமே வந்து நம்ம EDXRF மெத்தட் வந்து we can use it. So application clearly I mentioned environmental science, forensic department and parachemicals and paints and films and coatings. So films and coating வரும்போது very important point, last point. If I highlight these films and coatings, this EDXRF, these are the archaeological material. Recently we heard about through media that QAD. In QAD ல பாத்தீங்கன்னா நிறைய type of archaeological material வந்தது அப்படின்னு சொல்லுவோம். So in the archaeological material பாத்தீங்கன்னா these are the jugs and pottery samples and the different vessels and the coatings given on vessels. இதெல்லாம் என்ன type of material நமக்கு தெரியாது. So we can find out, because lifetime is very high. So we can identify the civilization of past human beings using the equipment based on elemental composition. வச்சுட்டு நாம வந்து ஃபர்தரா வந்து மூவ் பண்ணி அந்த ஹியூமன் பீயிங் உடைய அவங்க என்ன டைப் ஆஃப் கல்ச்சர் யூஸ் பண்ணாங்க. ஸோ தட்ஸ் வை we are very proud as a தமிழன், பிகாஸ் இந்த QADல கண்டுபிடிச்சதெல்லாம் பாத்தீங்கன்னா நம்ம தமிழ்நாட்டு மக்கள் வந்து நிறைய விதமான ஆர்டிஃபிக்ஸ் யூஸ் பண்ணிருக்காங்க, நிறைய விதமான டெக்னாலஜி. என்ன டெக்னாலஜி பாருங்க, ஒவ்வொன்றுக்கும் ஒரு டெக்னாலஜி இஸ் வெரி இம்பார்ட்டன்ட். நம்ம என்னென்ன டெக்னாலஜி யூஸ் பண்ணி இன்னைக்கு வந்து மெட்டீரியல் வந்து மேனுஃபேக்சரிங் பண்றோன்றது, அந்த மாதிரி வந்து QADல கிடைச்ச அந்த அகழ்வாராய்ச்சி மூலமா நிறைய டெக்னாலஜி யூஸ் பண்ணிருக்காங்க. டேட்டிங் அந்த எத்தனை வருஷத்துக்கு முன்னாடி கண்டுபிடிக்கிறது அது. பட் என்னென்ன டெக்னாலஜி, கெமிக்கல் கம்போசிஷனை வச்சு அது எந்த மெட்டீரியல் வந்து அந்த மெட்டீரியல் பண்ணோம்னா நமக்கு அதோட ஸ்ட்ரென்த் அதிகமா இருக்கும்ன்றதையும் நம்ம வந்து டிசைட் பண்ணலாம். So the previous one is a EDXRF. Then third one. So third one I will move on to the X-ray spectroscopy. So we know that the X-ray is discovered by Röntgen in 1995. So this X-ray spectroscopy also used in medicine, physics, material science, space science, chemistry, and archaeology. So this invention, we know that the Röntgen. So this image also first Röntgen discovered the X-ray. That X-ray is penetrated through the fingers through his wife finger. That ring also visible in the X-rays image. Today's whatever any bone fracture or any problem, when we go to hospital, they will take the X-ray, that bone fracture and any additional material present, any impurities are there, that will be identified in X-ray spectrum and X-ray scanning system. In material science, we can find out X-ray compounds and X-ray what are the chemical compositions and molecular formulas and crystal structures, especially structure of chemical compounds. This is the commercially available X-ray spectrometer. Even in SSN college also we have this X-ray spectrometer facility. So these some images of X-ray spectrum. The basic principle also same, similar to the EDXRF. Here the interaction of X-ray, but this is artificial X-ray source. That X-rays interact with any kind of material, liquid, solid, liquid, and gas. When we take solid materials, this is a protein crystal structure and the X-ray diffraction and some diffraction patterns produced for the environmental samples like a soil samples and atomic structures. So diffraction, basic principle. This diagram shows the basic principle of X-ray spectroscopy. Interaction of X-ray beam with the crystal that produces the 2 theta. Everyone aware about the Black's law. So this 2d sin theta is equal to n lambda. So based on this formula, we can find out the various patterns. So various different kind of single crystals that different shape and crystal structures are identified by the X-ray spectroscopy. And only one spectrum I have given. For example, here X-ray spectrum of crystal that H-scale values. H-scale in X-ray spectrum, 2 theta and intensity is very important. 2 theta scale 10, 20 up to 80. That different peaks using this H-scale values and the Miller indices. That is a Miller indices. That H-scale value used to find out the crystal nature and the crystal structures. And in our come to environment side, is a one particular soil type of is yield soil, is agriculture yield soil X-ray spectrum. So this X-ray spectrum shows the availability of common and very peculiar minerals in the soil. The soil mineral content is very important to growing the plant. If you growing the any type of plant. So before we cultivating the any type of material in agriculture soil, the soil testing is very important for mineral analysis. Once the minerals are very rich, then the soils are very suitable to find out the soils are suitable for cultivating the plant. So the basic and major minerals are quartz, kyanite, and calcium carbonate minerals and organic carbons. Organic carbons are almost present in the soil samples. Almost these strong peaks are represent the quartz. Nearly the 30 theta and 221 Armstrong, the thetas are represent that what quartz peaks. So identification usually through the JCPDS file. So nowadays we have JCPDS software that is installed. Once we got the 2 theta and intensity value, that is loaded to the spectrum and the required minerals data obtained from the spectrum. So users, we know that the X-ray structures can account for unusual electronic and elastic properties of material and shed light on chemical interaction and mineral contents. Even not only in the material science field, also in medical fields like biological molecules, including vitamins, drugs, proteins, and nucleic acids. Then very fundamental and every researchers starting with infrared spectroscopy. So this infrared spectroscopy, so infrared radiations interacted with again the solid, liquid, and gas molecules. The infrared spectroscopy region already we have in the electromagnetic spectrum. But in researchers, they are using the artificial infrared sources. So commonly used infrared spectroscopy is FTIR, Fourier Transform and Infrared Spectrometer. So that's a spectrometer almost near infrared spectrometer and far infrared spectrometer and mid-infrared spectrometer. For fingerprint region, like a mid-infrared spectrometer represents the 4000 to 400. That mid-infrared spectrum is very, very useful in all type of researchers. So mid-infrared spectroscopy covers the 4000 to 400 that produces the fundamental vibrations associated with the rotational vibrational structures. Mainly here very important the symmetrical stretching and symmetrical vibrational modes of atoms and molecules. I hope that you are studying lower class lasers, especially carbon dioxide laser, CO2 in carbon dioxide, two oxygens with one carbon that undergoes the symmetrical stretching, symmetrical stretching and symmetrical bending mode. So symmetrical stretching and asymmetrical stretching and symmetrical bending modes of vibration. So due to vibration, only the laser action produced. The energy absorbed energy is electrical energy, but produced light energy is light energy. The same way here, the typical available FTIR spectrometer. In FTIR spectrometer, the samples, liquid, solid, and gas, all samples are possible. But when we go to the solid type of material that should be in powder form, the two methods are used. Potassium bromide method, 1:2 ratio. Potassium bromide acts as a binder for sample. Then we have to make it into a pellet form. Around 0.15 meter or 0.15 centimeter, very few centimeter diameter of pellets are placed in the sample holder, then interact with the Fourier infrared spectrum of radiation, then spectrums are produced. And another ATR method, attenuation, reflection, attenuation, total reflection method. ATR means attenuation, total reflection method. That means no potassium bromide, raw samples are directly placed on the holder like X-ray diffraction. Then the required spectrums are produced from the rotation and the vibration of molecules. So infrared radiation interacted with atoms and molecules of sample, either symmetrical stretching and symmetrical vibration produced, then automatically the spectrum generated. This generated spectrum, these are the these are symmetrical equilibrium in bond length, stretching and compressing, and asymmetrical stretching bonds of vibrations. Yeah, an IR spectrum in absorption mode. In both absorption and transmitted mode, two modes are possible to record the spectrum. In absorption spectrum, the peak towards the y-axis in absorption mode. and in transmission mode, the peak towards the or that broad spectrum peak towards the y-axis. So classification of IR bands. So in IR, once the bands that absorption band or emission transmission bands produced, which one is strong, which one is medium, which one is weak. Maybe the content, chemical composition is very less or very high, very identification of chemical compounds. Like for example, see the length. IR bands classified as a strong, medium, and weak, depending on the relative intensities in infrared spectrum. A strong band covers the most of the y-axis. Most of the y-axis if covered, that is a strong. Medium, almost half of the y-axis. Weak means very few region of intensity is covered by the spectrum. So weak band, medium band, strong band. Once the strong peak is available, we can decide that particular chemical composition or chemical energy is available in the sample, like solid, liquid, or gas. Especially I told the compounds from gas in atmosphere, oxygen, nitrogen, and stratosphere and troposphere, different chemical gases are there. So that also possible to identify using these IR bands. Yeah, this basic information produced from the fingerprint region. So OH is touching vibrations, and the CH touching vibration shows around the 3000 centimeter units of wave number. And when used this chemical compound is 1-ibutanol, and C, because I'm not talking this is not environment, but one chemical compound, because we have to identify some chemicals. Even in the environment sample, that each and every minerals having that chemical name, chemical compounds. For example, you take quartz, SiO2, chemical is S silicon, S oxygen O. So yes, for silicon we have to get one peak, and for oxygen one peak coming. Similarly, calcium carbonate, you take calcium one peak comes, and carbonate, carbon C one peak comes, and oxygen one peak comes. So in this way, the chemical peaks are identified. See, for particularly nearly 1200 to 1000, there is some carbon and oxygen stretching mode of peaks. Similarly, the other peaks are generated in the spectrum. So IR absorption range in fingerprint region, see carbon-carbon and carbon-nitrogen and carbon double bond peaks and triple bond peaks, and other diatomic molecule region bonds are also identified with the different wave numbers. For this is the spectrum for alcohol. We commonly use the chemical compound in chemistry laboratory. And after used how to list out the frequency range and intensity. So the same compound identified from different frequency range, but which one is strong and medium and weak. So based on the identified frequency range, we can classify it as strong and weak. For environment, I will show this picture. These pictures are very special type of rock formed near to the Andaman Islands. These rocks are, once we make a powder form, these rocks are having a property nearly equivalent to the cement. So hence the special focus given on this type of rocks, Andaman and Nicobar Islands. These rocks are studied by FTIR. Why? Because in cement, we know cement basic compound is SiO2, and other chemical compounds are mixed with the cement industry, then only cement generated. The same way, what is the special components present in the material, that to identification is possible by FTIR. So this is the FTIR spectrum for that beach rock material. So the kyanite and organic carbon quartz. The quartz is the maximum content and microcline feldspar. These feldspar components are plays a major role in to increase the strength of the particular material, like in cement also. So that this beach rock, Andaman and Nicobar beach rock materials also having strength nearly equivalent to the cement since availability presence of feldspar minerals, but the strength is what? Very weak. Availability is there, but strength is very weak, not very strong. So in mineral identification, how to do the mineral identification? So silicon and oxygen tentative assignments so they're bending mode or vibrational mode. See that some bending mode and aluminum and oxygen stretching mode that produces the elite mineral, and the kyanite is a clay mineral. So say silicon and oxygen stretching mode that produces a kyanite mineral. But these tentative assignments are given based on the available literature, and mineral assignment also possible based on available literature. And these peaks, especially these 292, 2856 organic carbon, this assignment also we have given in mineral identification table is there from FTIR. So from there we can identify this. So but the only thing, after a spectrum generated, the separate data given, wave number and intensity and frequency. So that based on the data, we have to identify what are the peaks. So that the peaks automatically provides the peak number, that wave number and peak used to identify, and each peak value are equivalent to the tentative assignment. Silicon and oxygen of microcline. That means silicon and oxygen that bending mode and vibrational mode provides the microcline mineral. Similarly, the hydrogen, oxygen, hydrogen, nearly a water content H2O, that is stretching of water molecules provides the monochromite mineral, and the kyanite. So different vibration and stretching modes provides the kyanite mineral, but weak, strong or medium. So that also we can point out from the FTIR mineral identification from FTIR spectrometer. So basic applications also, it is similar to FTIR and EDXRF. So from forensic application, it's only identification. It's a qualitative treatment, not quantitative. But when we go for EDXRF, quantitative treatment. X-ray diffraction and the FTIR methods are qualitative. Only we can identify percentage and amount we cannot tell. Only simply we can identify. So then finally, ultraviolet spectroscopy. So the principle and the region, we know from electromagnetic spectrum, near ultraviolet region covers from 200 nanometer to 400 nanometer, and the far UV region covers from below 200 nanometer. So typical UV spectrometer available in the various industrial and laboratories. One important application I'm going to point out here. So the image, the right hand side image where I'm moving the mouse pointer. So this image shows the Kitasan thin film. There are wide application of UV spectroscopy. The mainly application is absorption property of material. We can find out the absorption property of material. So this is the Kitasan membrane. I have worked with this Kitasan membrane. So Kitasan is a biopolymer, usually which is derived from the crab. நம்ம நண்டுன்னு சொல்லுவோம் இல்லைங்களா, நண்டு அந்த நண்டுடைய ஓட்டுல இருந்து எடுக்கக்கூடிய ஒரு புரோட்டீன் தான் வந்து இந்த கைட்டோசன் சொல்லுவோம். அது வந்து நம்ம சிந்தசிஸா கெமிக்கல் லேப்லயும் பண்ணலாம். ஸோ அந்த புரோட்டீனுக்கு என்ன ப்ராப்பர்ட்டி இருக்குன்னு பார்த்தீங்கன்னா, அது வந்து ஒரு கார்போஹைட்ரேட். அதுல வந்து லோ விஸ்காசிட்டி, ஹை விஸ்காசிட்டி. as a physics person we know what is viscosity. low viscous, high viscous, medium viscous, 3 different layerல வருது. நம்ம medium viscous little bit costly, ரொம்ப கொஞ்சம் விலை கம்மி. ஒரு 5 grams பாத்தீங்கன்னா 6,000 rupees இருக்கும். So for deep research we purchased that, and we have prepared the thin film Kitasan membranes are thin films like cellotape மாதிரி இருக்கும் அது. So இந்த frame வந்து இதை எப்படி frame பண்ணோம் அப்படின்னா, we have a separate chemical method. அதுக்கு பேர் solution costing method னு சொல்லுவோம். அந்த மெத்தட்ல we have prepared solution costing னா sulfuric, we have to use the H2SO for sulfuric acid and Kitasan with a particular ratio, and drying method, and sodium hydroxide to remove of membranes. So once we prepared a proper and pakka membrane, so these membranes are used to filter the cancer causing heavy metals from contaminated water. So today everyone using the RO water system. That system RO system contains the various filter stages. So that the filters are what, degradable or not degradable, we don't know, biodegradable. But these membranes are degradable. So people who are living very near industry, there is a possibility of contamination of groundwater and surface water bodies. So that water may contains high toxic cancer causing heavy metals. So that heavy metals are possibility to filter by these type of Kitasan membranes. So these possibilities are studied by UV visible spectrometer. Only simple, this small piece cut and just placed in the sample holder and applied the UV visible spectroscopy. That UV visible spectrometer produces the spectrum with the wavelength and transmittance. So different wavelength range, we have the spectrum, CH1, CH5, CHU, CH9 represents the team, various composition of chitosan membranes. Various composition of chitosan with sulfuric acid, and the preparation method contains the various weightage of chitosan powder or chitosan carbohydrate polymer. For example, CH1 it contains maybe 2 grams. If CH5 contains maybe 3 grams. So in this case, so different absorption property, almost whatever content range, the absorption property gradually increases and it then becomes constant. Absorption property of heavy metals from contaminated water, like industrial effluent. Either when you take leather industry, this actually this spectrum is generated from industrial effluent after filtered, because the thin film contains the porous nature, very small porous. That porous are ready to accept the heavy metals, cancer causing heavy metals. So different wavelength ranges, 326, 415, 570. The different wavelength ranges absorbs the different heavy metals. Especially what is the chromium, mainly the leather industry. The chromium 3, chromium 6 are the mainly the cancer causing heavy metals. If you consume more than 15 or 10 years, there is possibility of affected by cancer, any type of cancer, but because of this contaminated groundwater. So to identify this, especially the chromium, that means this film behave as a chromium removal from your groundwater or industrially polluted water. So that is one of the main application in material science as well as in the environment side. In environment side, we have tested water. In material science side, material property, chitosan property also tested. Because material property, what property we identified? Absorption property. Then common application spectroscopy in astronomy. In astronomy, we know that the satellite in the Msc, minimal thermal emission spectrometry. So that spectrometry is used to test the rock soil in the atmosphere, and the Msc spectrometer to examine the mineralogy and rocks of soils, and alpha particle express spectrometer that used to test the rocks in soil of various plants in this, because the spectrometers are very tiny size that fixed in a spectrometer. They are testing. They're taking photographs is separate part, it's camera part, but analyzing part is this one, the spectrometer part one. And also Huygens mission. So this mission, we know that in astronomy side, which collects the data, Titan and Saturn, other planets, and what about the heat generated and other color components of the other planets' materials. So up to this I have covered, and almost I omit now atomic and laser spectroscopy, and directly I will move on to the carrier scope after the qualifying the MSc. So like this, laser spectroscopy, atomic spectroscopy, inductively coupled mass spectrometry, inductively coupled optical emission spectroscopy. So like this, we can study one by one. One by one, there are a lot of spectroscopies and in material science and environmental field. So I will complete my talk up to the spectroscopy. Then I received a request from organizer side to talk about the carrier scope after qualifying MSc, especially MSc Physics graduate. So sir, shall I discuss with your permission? Sir, am I audible?
Okay, sir. Okay, audible. You can carry, sir.
Thank you, sir. So with your permission, I will discuss with the career opportunities of after MSc graduates. So there is only two possibilities. One, we are looking for job opportunities, and another side we are looking for higher studies. So immediately we think about when we go for job, main employment you can go for as a lab supervisor, researcher, technician. I am talking about only MSc Physics graduates. MSc Physics graduates. Teacher, scientist, consultant physicist, research associate, senior physicist, assistant scientist, radiation oncologist, radiologist, professor. Well, where these type of positions are available, sir? See, research institutes, laboratories, educational institute, agriculture research, hospitals, aviation industry, aviation like aircraft manufacturing industries, construction firms and demolitions, and prototechnics manufacturers. So these are the companies offer these type of positions. So these are maybe private sector. So in private, apart from this, without related to your physics knowledge, but physics graduates are offered by different IT companies, Infosys, Wipro, CTS. Also energy plant and automobile industry. So once we go for job is the opportunity. Private sector side. And in government side, we have a research level of jobs in DRDO, Defense Research Development, Indian Space Organization, Space Application Center, Atomic Research Center, Oil and Natural Corporation, National Thermal Corporation, BHL, Bharat Electricals Limited, and Physics Research Laboratory, Nuclear Science Center, Indira Gandhi Center for IGK, Kalpakam, BRC, Baba Atomic Center, Kalpakam. They are offering the various scientist positions in their research level government jobs. So that freshers vary from 12,000 to 18,000 of salary, and annual income is nearly 10 lakhs. Even when apart from these all jobs, common people will go to the teacher job. That is also around 40,000 per month of in government and private sector jobs. So once we have private and government jobs, once you decide, you can opt any one of this. Then other side, only higher studies. So what are the higher studies? So job opportunity for MSc graduates in higher studies. Higher studies, first, I'm not talking about India, but so India or abroad, you have various positions for like IT consultant, security expert, and Java developer, interface engineer. Not only related with the computer, simple basic computer knowledge is enough, but they are offering MSc graduate physics graduates. Accenture, Facebook, Infosys, Great Research, KPMG, Barclays, and IBM. So there are many companies. These companies are from best countries, are US, China, Germany, Japan. So these countries are they are selecting the maximum MSc physics graduate students for this type of positions. And higher studies. In higher studies means immediately after MSc, we will move on to the Doctor of Philosophy, PhD or MPhil. So in PhD, the common PhD you can join with a stipend or without a stipend. So nowadays almost all the educational institutions providing the stipend for doing the PhD from minimum stipend of 10,000 to maximum 55,000-60,000 of stipend. When we do the common PhD, the two special PhD in two special branches plays a major role. There is a PhD in applied physics, PhD in biophysics. PhD in applied physics, we have basic job opportunities in various technology like ferroelectric and carbon nanotubes and photoelectric crystals and material plasma solar cell manufacturing industries, high-tech industries, medical labs, and scientific writings. And in biophysics side, after MSc, you can join PhD in biophysics, and you can go for the jobs in some parachemical companies and government hospitals, medical research labs, and environmental protection industries and defense services. Mainly we should we have to proud as a physics person, like a BSc physics or MSc physics. We should proud because almost our scientists are from the physics graduates. Albert Einstein, Isaac, whatever the scientist, Galileo, Richard Feynman. Even Richard Feynman is a father of nanophysics. He's also a physics graduate, father of nanoscience. Paul Dirac and Erwin Schrödinger, Ernest Rutherford. Almost these major scientists are MSc graduates, MSc physics graduates. So hence we should proud as MSc graduates. So hence up to this I will stop with my talk. Now I hand over the mic to organizer.
Thank you, sir.
Thank you, sir. Thank you for your valuable and innovative speech, sir. I hope the speech is useful to all the students and our faculty members, sir. Dear students, if you have any doubt, please ask to Dr. Chandrasekharan, sir. Students, do you have any doubts?
If you have any queries, you can raise now. Even our college also, we are providing almost stipend 13,000 stipend for PhD with free accommodation. you should have almost 70% in UG, PG, 10th and 12th level.
Sir gives you more suggestions about your careers. So any doubts, please ask to him. Okay, sir. Thank you, sir. Once
Thank you very
again,
much.
I thank to Dr. Chandrasekharan, sir, behalf of Department of Physics, Shanmuga Industries, Arts and Science College, joined as a chief guest in our webinar. Thank you so much, sir.
Thank you, sir. Thank you very much, sir. Shall I leave, sir?
Now I invite Dr. G. Lakshminarayan, sir, Assistant Professor of Physics, to give vote of thanks.
Good evening to one and all present here. This is wonderful opportunity for me to thank you all the participants. On behalf of the Physics Department, Shanmuga Industries Arts and Science College, Tiruvannamalai, I extend my gratitude to our Honorable Chief Guest, Dr. A. Chandrasekharan sir, to take out time from his busy schedule to deliver special lecture on spectroscopy and its application on environment. Thank you for inspiring and encouraging us with your words on this webinar. A special thanks to Mr. T.S. Muthu sir, Secretary and Correspondent, to given permission to conduct this webinar. And also I extend my special thanks to Mr. M. Srinivasan sir, Treasurer, for given wonderful inaugural address. My special thanks to our academic dean, Professor A. L. Udaipan sir, valuable suggestion to conduct this webinar, sir. A special thanks to our principal, Dr. K. Anandra sir, for giving the excellent speech in felicitation address and providing support to make the webinar successful. A special thanks to IQC coordinator, Dr. P. Murugan sir, HOD of Mathematics. I extend my gratitude to Dr. S. Armohan sir, Head of the Department, Physics, to organize a webinar even in the pandemic situation. I must thank the organizing team for working hard for the past few days to make this webinar successful. Finally, I thanks to all the faculty members and all the participants. Thank you everyone again for making it a great success. Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you so much, sir.
Sir, shall I leave, sir?
Sir.
Yes, sir. Yes, sir. Okay, sir.